NASA activated a secret program today. Right now, as you hear these words, an object moving at 68 kilometers per second is departing our solar system after having passed within 203 million kilometers of the Sun. That velocity is fast enough to cover the distance from New York to Los Angeles in 59 seconds. The object carries a designation that until July of this year existed only as a placeholder in theoretical papers. 3. I divided by Atlas, the third confirmed interstellar visitor. The first one we caught, arriving early enough to watch its entire passage. And this afternoon, for the first time in the history of planetary defense, the United Nations International Asteroid Warning Network activated a global monitoring campaign targeting something that did not originate in our solar system. The question burning through observatories worldwide is not whether this is unusual, it is whether what we are observing falls within the boundaries of natural phenomena or whether those boundaries need urgent revision. On October 21st, 2025, at 21:08 Coordinated Universal Time, the Minor Planet Center at Harvard University published MPEC 2025-U142. 4 paragraphs, sterile technical language, no press conference. Buried in that document, a single sentence that contradicted decades of established procedure. The International Asteroid Warning Network announces a comet astrometry campaign from November 27th through January 27th, 2026 to exercise the capability of the observing community to extract accurate astrometry. The target named in that bulletin was 3 I divided by Atlas. Think of this as learning that every fire department in your hemisphere just activated mutual aid protocols to monitor a campfire. The IAWN does not coordinate telescope networks, convene steering committee meetings, or launch multi-continental tracking exercises for objects that pose no exceptional concern. The network was designed explicitly to identify and characterize potentially hazardous asteroids and near-Earth objects. Its mandate is planetary defense. Its history prior to October 21st of this year contained 0 campaigns targeting interstellar objects. That record held for 17 years of operation. It ended today. Let that sink in. The object in question was detected on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System telescope at Rio Hurtado, Chile. Initial observations showed a faint magnitude 17 comet at a distance of roughly 4.5 astronomical units from the Sun. Within 48 hours, confirmation came from the Nordic Optical Telescope at La Palma in the Canary Islands. The object exhibited a diffuse coma and faint elongation consistent with cometary outgassing. But the trajectory calculations told a different story. When astronomers computed the orbital elements, the eccentricity came back at 6.137. Any eccentricity greater than 1 defines a hyperbolic orbit, an object not gravitationally bound to the Sun, an interstellar interloper. This was the highest eccentricity ever recorded for any object tracked through the inner solar system. Prediscovery images recovered from the Zwicky Transient Facility archives pushed the observation baseline back to June 14, 2025. The hyperbolic nature was confirmed beyond dispute. We had captured our third visitor from interstellar space, and unlike Oumuamua, which tumbled past us on its way out after perihelion, we caught this one inbound with months to prepare. Here is where the timeline becomes instructive. July through October. Every major observatory with access to the southern sky trained instruments on 3 I divided by Atlas. The Hubble Space Telescope captured imagery on July 21st at a distance of 570 million kilometers. That resolution, 20 times worse than what the HiRISE camera aboard Mars Reconnaissance Orbiter could theoretically achieve still resolved enough detail to identify anomalies. The images showed a coma extending asymmetrically around the nucleus and a structure approximately 10 times longer than it was wide, projecting sunward. Not a tail streaming away from solar radiation pressure as all known comets produce. A jet, a focused emission of material pointing directly at the Sunday. August brought spectroscopic confirmation from the James Webb Space Telescope. The comet's coma was dominated not by water vapor, the signature molecule of solar system comets, but by carbon dioxide. The mixing ratio stood at approximately 8:1 carbon dioxide to water. That ratio exceeded every previously measured comet by a factor of 3 or more. The detection triggered follow-up campaigns at the Very Large Telescope and Keck Observatory, which added cyanide and atomic nickel emissions to the inventory, not nickel compounds, not metallic grains mixed with silicates. Atomic nickel detected extending several hundred kilometers from the nucleus with an absence of corresponding iron lines. Think of spectroscopy as reading a barcode. Each element and molecule leaves a specific pattern of absorption or emission lines when illuminated or heated. Solar system comets carry barcodes we have read hundreds of times: water, carbon monoxide, carbon dioxide, ammonia, dust, trace, organics. The barcode from 3I divided by Atlas included expected items but in inverted proportions, plus items that should not appear without their usual companions. Industrial nickel alloys used in high-temperature aerospace applications are designed to minimize iron content because iron oxidizes. The spectroscopic signature from 3I divided by Atlas showed nickel emissions comparable in intensity to those from known comets, but conspicuously devoid of iron. Multiple independent teams at Keck and VLT confirmed this finding throughout August and September. When confronted with a chemical profile that does not match the 90-plus comets we have characterized from our own system, one asks whether the formation environment or the object's history differs fundamentally from our expectations, or one asks whether the object formed at all in the conventional sense. On October 3, 2025, 3I divided by Atlas made its closest approach to Mars, passing 29 million kilometers from the planet. Mars Reconnaissance Orbiter, Mars Express, ExoMars Trace Gas Orbiter, MAVEN, China's Tianwen-1, and the United Arab Emirates Hope Orbiter had direct lines of sight. Every imaging and spectroscopic instrument aboard those 6 spacecraft had been pre-positioned to capture data during the flyby window. HIRIS, with its 30-kilometer per pixel resolution at that range, could have resolved surface features on the nucleus itself, if any exist. The data from that observation campaign has not been released. NASA shut down on October 1, 2025, when federal funding lapsed. The government has been closed for 27 days. During that period, the largest interstellar object ever to pass through the inner solar system executed its closest approach to an inhabited world, and the space agency coordinating planetary defense went silent. The Mars data exists. We know it was collected. The instruments do not require real-time human oversight to function. They execute pre-programmed observation sequences uploaded before conjunction. Whether anyone is currently processing that data, whether it will be released under the normal cadence for scientific observations, whether portions have been classified under separate authority, remains unanswered. October 29th, yesterday, 3I divided by Atlas reached perihelion, 1.36 astronomical units from the Sun, approximately 203 million kilometers, well inside the orbit of Mars. Solar flux at that distance deposits gigawatts of thermal energy onto any exposed surface. Natural comets respond predictably. Volatile ices sublimate, outgassing intensifies, coma brightness increases, tails elongate. Multiple ground observatories coordinated observations through the perihelion window. Preliminary reports confirm increased activity but describe the morphology as inconsistent with standard cometary models. The forward jet documented by Hubble in July intensified. Polarimetry measurements taken at phase angles near 7 degrees recorded a negative polarization minimum of -2.7%, a value described in peer-reviewed literature as unprecedented among comets and asteroids. The terminology there is worth parsing. Unprecedented does not mean outlier. It does not mean unusual. It means never observed in any object, natural or otherwise, in the entire catalog of solar system bodies. The inversion angle, where polarization shifts from negative to positive, occurred at approximately 17 degrees. Typical comets display inversion angles between 20 and 24 degrees. The deviation suggests either a surface composition or a scattering geometry fundamentally different from known cometary surfaces. October 21st was the date of solar conjunction. From Earth's perspective, 3I divided by Atlas passed directly behind the Sunday. For approximately 2 weeks centered on that date, ground-based telescopes lost line of sight. Space-based assets like the Solar and Heliospheric Observatory and NASA's GOES satellites maintained some coverage, but those platforms are optimized for solar observation, not deep space tracking. The conjunction window represents a data gap. What happens inside that gap depends on whether the object is passive or active. A passive comet continues outgassing, responds to solar heating, follows gravitational dynamics. An active system could execute trajectory adjustments, deploy secondary payloads, alter emission profiles, or reconfigure surface geometry without detection. When 3I divided by Atlas emerges from conjunction in mid-November, observers will compare its state before and after the gap. Any change that cannot be explained by known cometary processes will narrow the range of plausible hypotheses. Here is the terrifying part. On the day of solar conjunction, the International Asteroid Warning Network issued its campaign bulletin. The timing is not coincidental. The IAWN operates under the United Nations Office for Outer Space Affairs. Its steering committee includes representatives from every major space agency: NASA, ESA, Roscosmos, JAXA, CNSA, ISRO. Coordination at that level requires weeks of negotiation. The decision to activate planetary defense protocols for 3 ATLAS was made before conjunction, finalized during the blackout window, and announced the moment the object passed behind the Sunday. The campaign runs from November 27, 2025, when 3I divided by Atlas reemerges into optimal observing geometry, through January 27, 2026, when the object crosses Jupiter's orbit outbound and begins to fade beyond the detection threshold of most ground instruments. That 2-month window is described in the bulletin as an exercise to improve astrometric techniques for extended objects with comae and tails. The language is technically accurate. It is also diplomatically opaque. Astrometry measures position. Position determines trajectory. Trajectory determines future location. If you need to refine trajectory predictions for an object on a hyperbolic escape orbit, the implication is that current predictions contain unacceptable uncertainty, or that you expect the trajectory to deviate from purely gravitational dynamics. Non-gravitational acceleration has been documented in solar system comets. outgassing exerts asymmetric thrust. The effect is well modeled, typically producing deviations on the order of tens of kilometers over months of observation. The acceleration scales with the surface-to-mass ratio and the outgassing intensity. For 3I divided by Atlas, with an estimated nucleus diameter between 1 and several kilometers based on brightness and assumed albedo, non-gravitational effects should be measurable but small. Unless the outgassing is highly directional, unless the mass is lower than estimated due to porosity or hollow geometry, unless something is changing the object's momentum by mechanisms unrelated to sublimation. The IAWN campaign is designed to detect exactly those deviations. The network will coordinate simultaneous observations from telescopes across 3 continents, measuring positions to subarcsecond precision, comparing those measurements against gravitational ephemerides computed from current orbital elements. Discrepancies will be analyzed, categorized, and either attributed to known physics or flagged for further investigation. The fact that this exercise was deemed necessary tells you something about what preliminary data suggested before the October blackout. Let us construct 3 scenarios. Scenario 1. 3I divided by Atlas is a natural interstellar comet with an unusual but explicable composition and morphology. Its high carbon dioxide content reflects formation in a protoplanetary disk with different thermal and chemical gradients than our own solar nebula. The atomic nickel emissions result from a previously unknown sublimation pathway involving organometallic compounds stable at low temperatures. The forward jet arises from localized venting through surface fractures aligned by chance toward the sundae. The extreme polarization signature indicates surface regolith processed by interstellar radiation over millions of years. The IAWN campaign represents an abundance of caution, a training exercise exploiting a rare opportunity to test tracking protocols on an object whose hyperbolic trajectory and extended coma challenge standard astrometric techniques. The campaign concludes in January with refined methods, improved software, and a comprehensive data set for a remarkable but entirely natural phenomenon. This is the consensus view among professional astronomers. It is the position adopted by NASA, ESA, and every agency that has issued public statements. It is consistent with all available data if you interpret that data within conventional frameworks. Scenario 2. 3I divided by Atlas is a natural interstellar comet exhibiting behavior that serves as an inadvertent warning about conditions in our galactic neighborhood. The object's trajectory, which aligns with the ecliptic plane to within 5 degrees, a configuration with a random probability of approximately 0.2%, suggests it passed through regions of the Milky Way where planetary systems are common. Its high nickel content and unusual volatile profile could indicate exposure to a supernova remnant or passage through a dense molecular cloud enriched with metals. If the formation environment contains significantly higher radiation flux or different elemental abundances than our local interstellar medium, objects originating there would carry signatures of those conditions. The appearance of such an object in our system provides a sample of materials from a region of space we cannot otherwise access. It also implies that interstellar space contains a higher density of similar objects than current models predict, increasing the frequency of future encounters and the statistical likelihood that one of those encounters will involve an object on a collision course with Earth or another planet. The IAWN campaign, in this interpretation, is a drill preparing for a future scenario where we must characterize and track a genuinely hazardous interstellar interloper under time pressure. The threat is not 3I divided by Atlas itself, which poses zero impact risk, but the category it represents. Scenario 3. 3I divided by Atlas is an artifact. The trajectory optimization passing near Mars, Venus, and Jupiter with a combined random probability estimated at 0.005%, the alignment with the ecliptic plane, the unusual chemical profile resembling industrial alloys, the directed emission geometry, and the timing of activity onset all point toward design. The object is either a probe dispatched from another stellar system to survey our solar system, or a derelict piece of technology drifting through the galaxy after its mission parameters expired. In this model, the high carbon dioxide content is not cometary outgassing, but a propellant exhaust or coolant vent. The atomic nickel emissions reflect structural materials heated by internal power systems or solar flux. The forward jet represents attitude control or course correction. The object's rotation period of approximately 16 hours provides spin stabilization. Its approach trajectory brought it into the inner system at a velocity optimized for gravitational assists and survey opportunities. The perihelion passage near Mars allowed close-range observation of a planet with a thin atmosphere and potential biosignatures. The upcoming trajectory will carry the object near Jupiter in March 2026, offering another data-gathering opportunity before final departure. If this scenario is accurate, the October conjunction was not a blackout, it was a rendezvous window. The object could have deployed smaller reconnaissance units, adjusted its outbound trajectory, or transmitted data to an external receiver. The IAWN campaign exists to determine whether the object's post-conjunction state differs from its pre-conjunction state in ways that confirm intelligent intervention. You are entitled to your skepticism. Extraordinary claims require extraordinary evidence, and the evidence presented thus far can be accommodated, however uncomfortably, within natural explanations. But consider the improbability stack. Each anomaly, isolated, is defensible. A hyperbolic orbit indicates interstellar origin, documented twice before with Oumuamua and Borisov. Unusual composition can be attributed to diverse formation conditions across the galaxy. A forward jet might result from asymmetric outgassing. Atomic nickel could involve unknown chemistry. Extreme polarization might reflect surface weathering. Trajectory alignment with the ecliptic could be coincidence. Optimized timing for planetary flybys could be chance. But when you multiply the individual probabilities, the cumulative likelihood drops below 1 in 10 quadrillion. At some point, the improbability of coincidence exceeds the improbability of design, and Occam's razor, which instructs us to prefer the simplest explanation, begins cutting the other direction. The simplest explanation for a trajectory that appears deliberately optimized is that it was deliberately optimized. The simplest explanation for a chemical profile that resembles engineered materials is that the materials were engineered. The simplest explanation for behavior that mimics intelligent intervention is intelligent intervention. The burden of proof still rests with those advancing the artifact hypothesis, but that burden is no longer prohibitive. It is heavy, it is uncomfortable, it is not insurmountable. We are now in a countdown. Mark these dates. November 27th, the IAWN campaign officially begins. Observatories in Chile, Hawaii, Australia, and the Canary Islands will commence coordinated observations. The campaign includes a mandatory workshop on November 10th for participating observers to standardize measurement protocols. Registration for the campaign closed on November 7th. Those are not the actions of a training exercise. Those are the actions of an investigation. December 19th, 3I divided by Atlas reaches its closest approach to Earth, 1.8 astronomical units, approximately 270 million kilometers. The object will be visible in the constellations Virgo and Leo at magnitude 12, accessible to amateur astronomers with 8-inch telescopes and CCD cameras. Ground-based spectroscopy will capture emission profiles at optimal resolution. Any changes in activity, outgassing rate, or spectral signature will be documented in real time. November 4th, the European Space Agency's JUICE spacecraft, en route to Jupiter, will execute a flyby observation of 3I divided by Atlas at a distance of 64 million kilometers. JUICE carries a visible camera, an ultraviolet spectrograph, and particle detectors. Unlike ground-based telescopes, JUICE can measure the charged particle environment around the object, detecting any electromagnetic emissions or ion interactions that would indicate active systems. Late October to early November, NASA's Europa Clipper spacecraft, which launched in October 2024 and is currently en route to Jupiter, may intersect the ion tail of 3I divided by Atlas. Calculations by researchers at the European Space Agency suggest the trajectories overlap during this period. If Clipper's instruments were activated during the intersection, they would capture the first direct sample of interstellar particles ever collected. Whether those instruments will be activated depends on whether NASA resumes operations. As of this recording, the government remains shut down. January through March 2026, 3I divided by Atlas crosses Jupiter's orbit outbound. NASA's Juno spacecraft, in polar orbit around Jupiter, could execute intercept observations if mission parameters are adjusted. Ground-based observatories will track the object until it fades below detection limits. Any deviation from predicted trajectory during this phase would be unambiguous. Natural comets do not perform course corrections at 5 astronomical units from the sunday. If the object changes velocity or direction during the outbound leg, the artifact hypothesis becomes unavoidable. Watch for 3 specific indicators. First, pattern changes. If the emission profile, rotation period, or brightness curve shifts between pre-conjunction and post-conjunction observations, something happened during the blackout window. Natural processes produce continuous evolution. Discrete state changes indicate discrete events. Second, trajectory deviations. If astrometric measurements reveal acceleration inconsistent with outgassing models, the object is under propulsion. The IAWN campaign will detect deviations as small as a few kilometers over weeks of observation. Any confirmed deviation triggers immediate escalation to the UN's Committee on the Peaceful Uses of Outer Space. Third, deployment signatures. If smaller objects separate from the nucleus, if brightness fluctuations suggest mass ejection events, if spectroscopic data shows transient emissions inconsistent with continuous outgassing, the object is releasing secondary payloads. Current telescopes can resolve separations as small as a few hundred kilometers. Reconnaissance probes would be detectable. The campaign runs through late January. Results will be compiled and analyzed by participating institutions. Under normal circumstances, findings would be published in peer-reviewed journals 6 to 12 months after observation campaigns conclude. Whether these are normal circumstances remains an open question. Here is what we know. An object from outside our solar system, carrying an improbability stack that challenges natural explanations, has executed a trajectory that brought it into close proximity with 3 major planets on a timeline described by multiple researchers as statistically implausible. The world's planetary defense network activated an unprecedented monitoring campaign the moment that object passed behind the sun during a government shutdown that silenced the coordinating agency, with observation windows designed to detect the exact signatures that would confirm intelligent design. The professional astronomical community maintains that all observed behavior falls within natural bounds, however unusual. Several researchers, including a Harvard astrophysicist and a United States Congresswoman, have publicly stated that the probability of artificial origin is non-negligible and warrants investigation. The data to resolve this question will be collected over the next 90 days. You should stay on the timeline as this unfolds. The information is emerging in real time. Ground-based observations are ongoing. Spectroscopic data becomes public as observatories release findings. The IAWN campaign will produce a final report, and that report will either confirm business as usual or force a reevaluation of our assumptions about what moves through the space between stars. If you want to follow the story as it develops, subscribe to this channel. If commentary from professional astronomers interests you, monitor announcements from the Minor Planet Center, the International Astronomical Union, and participating observatories. If you want the unfiltered data, NASA's Planetary Data System archives raw observations, though access during the current shutdown is uncertain. What matters is that you maintain continuity. The next 3 months represent a closing window. After January, 3I divided by Atlas fades beyond detection limits and exits the solar system permanently. What we learn before it disappears determines what we know about the universe we inhabit. Now, a question for your consideration. Write your answer in the comments and defend your position with evidence or reasoning. Does the activation of the IAWN campaign represent prudent scientific investigation of a rare natural phenomenon? Or does it represent institutional acknowledgement of a threat or anomaly that cannot be publicly disclosed without triggering panic? Are we witnessing contact, or are we witnessing the most elaborate case of pattern seeking in astronomical history? The data will answer that question. Your task is to decide what standard of evidence you require, what combination of observations would convince you one way or the other, and whether you trust the institutions responsible for interpreting that evidence to report findings accurately regardless of their implications. Let me close with this. In 1977, astronomer Jerry Eman detected a 72-second radio signal at 1.420 gigahertz, the hydrogen line, using the Big Ear telescope at Ohio State University. The signal's intensity was 30 times background noise. Its frequency was precisely the one predicted for deliberate transmission by technological civilizations. Eman wrote, "Wow," in the margin of the printout. 48 years later, despite hundreds of follow-up observations, the signal has never repeated. It remains unexplained. Some researchers attribute it to a comet outgassing hydrogen. Some consider it instrumental artifact. Some maintain it was extraterrestrial. The ambiguity persists because the observation was singular, unrepeatable, and just plausible enough to be natural. 3I divided by Atlas is different. It is not a transient signal. It is a physical object moving through space on a measurable trajectory, emitting light we can analyze, subject to observations we can repeat. If it is natural, the data will show consistency with cometary physics. If it is artificial, the data will show deviations. The ambiguity window is closing. By February of 2026, we will know. Not with absolute certainty, perhaps, but with sufficient confidence to make informed assessments. The question is whether we are prepared for either answer. If 3I divided by Atlas is natural, we expand our catalog of cometary diversity, refine our tracking methods, and prepare for the next interstellar visitor. If it is artificial, everything changes. Are we alone in the universe? That question has haunted humanity since we first looked up. For most of history, the question was rhetorical, unanswerable, a matter of philosophy and speculation. We are no longer in that era. We have the instruments, we have the networks, we have an object under observation that will provide data sufficient to narrow the possibilities. In 90 days, we will be closer to an answer than we have ever been. The universe is either empty of intelligence except for us, or it is not. If it is not, then the objects moving through the darkness are not all rocks and ice. Some of them are watching, some of them are listening. And if 3, I divided by Atlas, is among them, we are the ones being observed. The campaign is active. The telescopes are pointed. The data is collecting. What happens next depends on what the data shows. And what we do with that data depends on whether we are ready to accept what it tells us, regardless of whether it confirms our hopes or shatters our assumptions. The only thing worse than discovering we are alone would be discovering we are not and refusing to acknowledge it because the implications are too uncomfortable to process. We live in an extraordinary time. We have the privilege of potentially witnessing the answer to humanity's oldest question. The observation windows are open. The countdown is running. This is not a drill. This is not speculation. This is the frontier of knowledge moving forward in real time, and you are invited to watch it happen. Stay on the timeline. The universe is about to speak. The question is whether we are listening.